Good morning, students. So today we are going to discuss a new topic called the integration by partial fractions. Yesterday during the class we had very light discussion on this. How to perform, how to leverage the method of partial fractions to perform integration. And yesterday I said that today I will be discussing in details about the process to be followed, in partial fraction, and there are different cases in what case we'll perform what kind of partial fractions. Partial fractions is a topic of algebra, but what we get at the result of the partial fractions has immensely valuable for solving indefinite integration questions. Hence, there is a valid justification that why we should learn today while we are learning how to perform integration. So, if you recall, I hope all of you are able to view the screen very clearly and able to hear my voice very clearly.
Yes.
Okay. If you recall, when we had our differential calculus discussion, we performed the differentiation of product of two functions. We perform differentiation of division of two functions, correct or not?
Yeah.
And here also we did in one of our previous class how to perform that u into v dx, right? Integration of product of two functions, correct or not? So here what you are going to learn that how to integrate when there are two functions actually divided by each other. Got my point? That means what we are going to do, we are going to do the perform integration of px by qx. Got it, no? Where px is a function of x and qx is a function of x. But here, px and qx are a special type of functions. They are, polynomial functions. Got it, right?
Yeah.
That means px could be a polynomial function of degree 2, qx could be a polynomial function of degree 3, px could be a polynomial function of degree 1, qx to be a polynomial function of degree 3, 2, whatever. Or could be the other way also. Px could be the polynomial of degree 2 and qx is a polynomial of degree 1. That is also possible. Now, from the point of, that is called a rational fraction. Okay, got my point, dear students? That is actually called a, what is called, it is called as a rational function. Correct? So this is a rational function. Now, that rational function, px by qx, is known as a proper rational function and improper rational function depending on the relationship between the degree of px and qx. Correct? So, if degree of px is less than degree of qx, okay, qx, so we can say that px by qx is a proper one. Qx by qx is a proper rational function. Now, if degree of px is greater than degree of qx, then we can say that px by qx is an improper rational function. These are just terminologies. We should know the terminologies and their, actual meaning. Is an improper rational function. Now let's consider. So this is the 1, and this is 0.2. When we have the degree of px is greater than degree of qx, so how we can write px by qx? We can write px by qx something like this. Dear students, we can write, if you remember the Euclid's division lemma, we can get a quotient sx into qx, correct or not? Sx into qx, and plus we'll get one remainder, correct or not?
Yes.
Clear or not clear?
Yes.
So in fact, I wrote little wrong. So px should be like this. We can express px equal to sx into qx plus rx, where sx is known as the quotient and rx is known as the remainder. If you recall the Euclid's division lemma.
Yes.
So this implies px by qx, and obviously, dear students, in all this discussion, qx is never 0 for any value of x. Because if qx is equal to 0, then whole point of is of no meaning of discussion, correct? No?
Yes.
So we can easily divide by, qx. So we can write this is equal to sx plus rx by qx. Clear or not clear? Now, obviously, the degree of the remainder polynomial must be less than that of the, qx. Degree of rx is definitely less than degree of qx. No?
Yes.
Otherwise, the whole discussion, the whole division doesn't make sense.
Yes.
So what we can get? So we can get integration of px by qx dx should be equal to integration of sx dx plus integration rx by qx dx. Clear or not clear?
Yes.
Now, if you look into this case, the first one, that px by qx, this integration. So here what we wanted to do, px by qx dx, no, first case. In this case, what happened? The degree of px is less than degree of qx. Correct or not? In this case, all of you agree to me?
Yes.
Means px could be a linear polynomial, qx could be a quadratic polynomial. Or px could be a quadratic polynomial, qx could be a cubic polynomial. Or px could be a linear polynomial, qx could be a cubic polynomial. Means, in single statement, what we can say, the degree of px is less than degree of qx. And here also in this case, if you look into it, the degree of rx is less than degree of qx. Dear Sagnik, absolutely clear? Gurman, Divansu?
Yes, sir.
Disha?
Yes, sir.
Okay. So then the whole point now actually come to a, entire discussion is now converging to a single point, is that how we can perform the integration of px by qx where degree of px is less than degree of qx, isn't it? Because when the degree of px is greater than degree of qx, what we get? Integration of sx plus integration of rx by qx. What you see here? Integration of sx is very easy to do, correct or not? Integration of sx is a polynomial. Polynomial function integration is so easy to do. You just need to apply the formula of integration x to the power n dx, correct or not?
Yes.
So the whole point converging to a single statement that we want to perform the integration of px by qx where the degree of px is less than that of qx. Clear? So now whatever I said, that entire thing, I just want to keep it here, the theoretical discussion, and I want you to please have a look into it, quick look into it. I recommend each one of you just have a look into the each and every statement. Whatever I said is actually described here, and if something is not clear, do let me know.
Yes.
I just give 2 minutes for you to self study the portion I actually made available to you. Goodman, is it fine?
Yes, sir.
Yeah, please go ahead. Okay, so you understood that the entire point is now converging to find the integration of a numerator polynomial by denominator polynomial, where
Yes.
the degree of the numerator polynomial is less than the degree of the denominator polynomial.
Yes.
Now the question is that how we are going to do it, correct? And
Yeah.
so for this kind of, then in other term, what we can see is that we found integration. We need to find the integration of proper rational function, isn't it? All of you understood my point?
Yes.
Because when the degree of the numerator polynomial is less than the degree of the denominator polynomial, that is known as a proper rational function. In single term, we can say that how to perform the integration of proper rational function.
Yeah.
Okay.
Yes.
So I'm just going to share one table with you, dear students, and we need to strictly follow this table. Okay. And things will be absolutely clear how to perform integration. You just need to make this table handy and so that and things will be absolutely clear. Okay, and we'll do some representative question also, together. And it will be good. You can also write down this table so that it will be helpful for us to solve problems. So what it says that when the rational function is in the form of px plus q by x minus a into x minus b, the first case, then we should express that rational function, in fact, more properly to say the proper rational function in the form of a by x minus a plus b by x minus b. And we will see how we can find the value of capital A and capital B. Capital A and capital B are what? They are real constant.
Yeah.
There are steps to find the values of capital A and capital B. The moment we found this one, then integration of px plus q by x minus a into x minus b dx become easy. Correct?
Yes. Yes.
So what happened? If I write it here, the moment we found out that how to perform that, the moment we found out the value of a capital A and capital B, then integration px plus q divided by x minus a into x minus b dx should become, capital A is a real constant, it will be taken out, correct or not?
Yes.
Dx by x minus a plus capital B integration dx by x minus b.
Yeah.
And we know integration dx by x minus a is nothing but ln of mod x minus a.
Yes.
And integration of dx by x minus b is ln of mod x minus b plus integrating constant c.
Yes.
So that is the valid justification that why we should leverage the concept of partial fraction, which is an algebraic simplification concept to be applied here in the integration.
Yes.
Now think about the second case. The first case we just discussed. Think about the second case. First case we just discussed. Think about the second case. Is that, by the way, one point is that in the first case, if you see the denominator is x minus lowercase a into x minus lowercase b.
Yeah.
And one condition is that a lowercase a should not be equal to lowercase b. In that case, we cannot perform, the partial fraction of this type.
Yes.
Okay.
Yes.
Now, in case that a is equal to b, then the case 1 is actually getting transformed to case 2, correct or not? It denominator become x minus a whole square.
Yeah.
Then what happened is that integration, then we will write the partial form of partial fraction for this particular rational function, that is px plus q by x minus a whole square, is equal to capital A by x minus a plus capital B by x minus a whole square. Why so? For that, we can deep dive into the rational function and partial fraction and partial fraction representation of rational function, that we can do in some separate class. But for the time being, you assume this is the form, and that's why I said few minutes back, you need to remember this table very well. Then what happened? Here you will find integration of px plus q divided by x minus a whole square dx. Correct, na, dear students? So that becomes, capital A outside dx by x minus a
Yeah.
plus capital B integration dx by x minus a whole square.
Yes.
Integration dx by x minus a, you already know, it is ln of mod x minus a. And similarly, integration dx by x minus a whole square, if you find this, little difficult, very little, then you can make a substitution x minus a is equal to t, then dx equal to dt, so dt by t square, so it will get t power minus 1 by minus 1, correct now? And then you apply back the value of t, that is x minus a, or directly you can write it is x minus a power minus 1 by minus 1, correct or not? All of you got it?
Yes.
All of you got it, right? Gurman, Divansu, Disha, Srijita, you got it?
Yes.
Yes.
Great. All right. Now the third case is that if you see the denominator is a cubic polynomial, x minus a into x minus b into x minus c, and numerator is a quadratic polynomial. Got it? Then it is very simple. You write this as a capital A by x minus a plus capital B by x minus b plus capital C by x minus c. Then what will be its integration? Integration of px square plus qx plus r divided by x minus a into x minus b into x minus c dx is equal to capital A into integration dx by x minus a plus capital B integration dx by x minus b, correct?
Yes.
Plus capital C integration dx by x minus c. And I think I no need to say how to perform the integration, each of this integration in the right hand side. It is so simple. Correct?
Yes.
Now let's come to point 4. Point 4 is that when you find that the numerator polynomial is a quadratic one, and the denominator polynomial is a cubic one, but it is little different way of expression. That is, here it is x minus a whole square into x minus b. Correct? No?
Yes.
In this case, how we will perform the integration? Integration will be px square plus qx plus r divided by x minus a whole square into x minus b dx is equal to capital A will take outside integration dx by x minus a plus capital B integration dx by x minus a whole square. Correct, no?
Yeah.
And capital C outside integration dx by x minus b. Correct or not?
Yes.
Now comes the right hand side integration. I hope I no need to explain because we already explained so many times earlier also and today also. For the fifth one, if you see, the numerator is a quadratic polynomial, but the denominator is a cubic polynomial, but which is expressed as a product of a linear polynomial and a quadratic polynomial, in which the quadratic polynomial cannot be factorized. What is the quadratic polynomial? X square plus bx plus c. You see here, dear students.
Yes.
And we are not able to factorize x square plus bx plus c. If we factorize, then it actually turning out to be either case 3 or case 4, isn't it?
Yes.
If you look it minutely. Shagnik, are you getting my point?
Yes, sir.
So then in this case, what we are going to do? In this case, we need to express that rational function, okay, in the form of capital A by x minus a plus bx plus c, capital Bx plus capital C by x square plus bx plus c. Okay. So then what will be our integration? Integration will be px square plus qx plus r divided by x minus a into x square plus bx plus c dx is equal to capital A we take outside, integration dx by x minus a plus integration bx plus c dx divided by x square plus bx plus c. In the right hand side, dear students, you know how to integrate dx by x minus a.
Yeah.
Actually, you also know how to integrate bx plus c dx divided by, ax x square plus bx plus c. You can use just a substitution. You can take x square plus bx plus c is equal to t. Then you differentiate, you will get to x, plus b dx is equal to dt. So that you can adjust with the numerator bx plus c. We'll see. Okay, and then you need to apply formula of x square plus s square, denominator dx by x square plus s square, or x square minus s square, depending on the values of this constant, capital B, capital C, and lowercase b, lowercase c. We'll see. Means what I'm saying is that the integration, what I marked in the blue color, we know how to do it, but let's take some real examples so that it will be very clear to you.
Yes.
But before we proceed with some representative, problem, and I want you to just write down this table in your notebook.
Yes.
It can take a couple of minutes. In the next half an hour, we are going to spend how we can find the values of capital A, capital B, capital C as their real numbers. So we'll see how to find the values of these capital A, capital B, capital C. We discussed little bit yesterday, but today we'll see. Either you can it become an identity. Okay, that form of the rational function, what you see in the left hand side, is, and form of the partial fraction, what you see in the right hand side, both are actually, equal. That is identity. And what is then a rule of an identity? Left hand side of the identity is equal to the right hand side of the identity for any value of x. We can apply any value of x to find that one. Or another technique is that we can equate the coefficient of the like terms of the left hand side with the like terms of the right hand side. What does it mean? It means that, the coefficient of x square in the left hand side should be equal to the coefficient of x square in the right hand side. Coefficient of x in the left hand side should be equal to the coefficient of x in the right hand side. The constant term in the left hand side should be equal to the constant term in the right hand side. I can tell you in brief while you are writing in your notebook. You can just have a look into it. Just this is a generic discussion. It is, let me use a different color. Suppose you get an identity something like this. P into x cube plus q into x square plus r into x plus s is equal to, a into x cube plus b into x square plus c into x plus d. Suppose you come up to this kind of identity. Suppose this is an identity. Got it?
Yeah.
Then what we can conclude? We can conclude that this p, what you see is the p, that is the coefficient of xq in the left hand side, must be equal to the coefficient of xq in the right hand side, which is
Equals to A.
they has to be equal to each other. Got it?
Yes.
The coefficient of coefficient of x square in the left hand side, which is q, must be equal to the coefficient of x square in the right hand side, that is b. Got it, no? They have to be equal. They have to be equal to each other. That's why I give a different color, so that you can later make a distinction between what I'm talking about. Similarly, the coefficient of x in the left hand side, that is r, should be equal to the coefficient of x in the right hand side, that is c. They also have to be equal to each other. And finally, the constant term, as you see, dear students, the constant term, which is s in the left hand side, must be equal to the constant term d in the right hand side. That is one approach. Sorry. That is one approach. We can use it. And another approach is that you can apply any value of x in the left hand side, and the same value, then you will find a value in terms of p, q, r, s. That should be equal to in terms of right hand side a, b, c, d. Then you will get linear equations, and you do solve those linear equations.
Okay.
We'll see by means of an example. Now, can you proceed to solve some examples, dear students?
Yes.
Okay. The first example, what we are going to do is that, integration of dx by x plus 1 into x plus 2. Simple. You can also do along with me. So what is the question here? Question here is that integration of, so question 1. Here we are going to do integration of dx by x plus 1 into x plus 2. So what is our rational function? Our rational function is 1 by x plus 1 into x plus 2, correct or not?
Yes.
So if you look into the table, we can write this as capital A by x plus 1, isn't it, dear students?
Yes.
Plus capital B by x plus 2. So from here, what we are going to get? From here, we are going to get 1 is equal to capital A into x plus 2 plus capital B into x plus 1. Obviously, x plus 1 into x plus 2 is not equal to 0. It
Yeah.
is quite obvious because if it is equal to 0, then the question doesn't make sense at all.
Yes.
It's not equal to 0.
Yes.
So from here, there are two approaches we can take. Let me actually discuss both the approaches. First approach is that substitution of the value of x, and second approach is that equating the coefficient of the like term. Okay, so let's take both the approaches. The first approach. So what we are going to get from here is that and second approach you will take it here. The first approach, what we are going to do is that we are going to take that we say here we are applying the value of x is equal to minus.
Minus.
If we apply the value of x equal to -1, left hand side is 1, right hand side is a into -1 plus 2 plus b into -1 plus 1. Correct or not, dear
Yes.
students?
Yes.
So from here, what we get? The value of a is equal to 1. Correct or not? Now, we apply a different value of x to, find the value of the other constant, that is capital B. And the right value to apply for x is equal to -2.
Yes.
Correct? Huh?
Yes.
This implies left hand side it will be 1, right hand side a into -2 plus 2 plus b into -2 plus 1. So if you simplify, you will get b is equal to -. Now, is it the only two values of x, that is -1 and -2? Not really. You can apply any value of x.
Yes.
Okay, you can apply any value of x to get it done. You can take the value of x equal to +1. You will get one equation. So let's do this thing so that it will be helpful for you to understand. So this is already you achieved it. Now let's apply x is equal to 1. If we apply x is equal to 1, what we are going to get? Left hand side is 1, right hand side a into it is 3a plus 2b. Correct or not?
Yes.
3a plus 2b. And now let's take another value, x is equal to 2, for example. So what we are going to get? We are going to get 1 is equal to 4a, correct or not? Plus 3b. These two are, pair of linear equations.
Yes.
Now you can solve these linear equations and you will get the exact value of a and b as 1 and -1. What we achieved.
Yes.
Clear or not clear? So this method is that by substituting the value of x. Correct or not? So this method is called the substitution of the values of x.
Okay. Yes.
Okay. Now the right side, so this is the method what we just learned. Another method is that equating the like terms. Equating the like terms. Let me use a different color to explain this thing. So let me use this color. So that entire expression, what we can write is that 1 is equal to capital A plus capital B into x. Isn't it, dear students?
Captain A plus Captain B.
Because right hand side, ax plus bx, so a plus b into x, na?
Yes.
Plus 2a plus b. So what we can write is that we can write, 0 into x plus 1 is equal to a plus b into x plus 2a plus b. Correct or not?
Yes.
Now, as we just discussed, in an identity, the coefficient of x cube in the left hand side should be equal to the coefficient of x cube in the right hand side. Coefficient of x square in the left hand side should be equal to the coefficient of x square in the right hand side. Coefficient of x in the left hand side should be equal to the coefficient of x in the right hand side. The constant term in the left hand side should be equal to the constant term in the right hand side. So what we can conclude? The coefficient of x in the left hand side is 0.
A plus B equals to 0.
That should be equal to the coefficient of x in the right hand side, that is a plus b. And constant term in the left hand side is 1. That should be equal to the constant term in the right hand side, that is equal to 2a plus b. So if you solve these two, you see the value of a is equal to minus b. Correct or not?
Yes.
So b is equal to minus 1 and a is equal to 1. If you solve these two linear equations, definitely you will get a is equal to 1 and b is equal to minus 1, what we already achieved.
Yes.
So now you can ask, sir, what approach I should take? It depends on case-to-case basis. Sometime when you get a quadratic one in the left-hand side and right-hand side, I will suggest you to use the method of equating the like terms.
Oh.
Okay? Or you can take that substitution of the values of x. Both the approaches you can take. But anyway, these two methods are very well understood, dear students. All of you got it very clearly. Gurman, did you get it very clearly?
Yes, sir.
Okay. Divanshu, Sagnik,
Yes, sir.
Disha. Okay. So then, Disha, absolutely clear?
Yes, sir.
Okay. So then, this entire integration is now left with what? This entire integration is now left with, this is equal to, we already found the value of a, that is 1. So that is integration of dx by x plus 1. Correct or not?
Yeah.
Now b is minus 1 minus integration dx by x plus 2. So we know what is the integration of dx by x plus 1. It is ln of mod x plus 1. I hope I no need to explain because we have done several times. And this is ln of mod of x plus 2. And plus 1 integrating constant c. That is equal to ln of mod x plus 1 by x plus 2 plus c.
Yeah.
Correct or not?
Yes.
Where c is integrating constant. If things are absolutely clear, then you can proceed to the next question.
Yes.
Okay, so now let's proceed to the next question. Next question is, you can write down. Let me first write down, then you can, let me go to the next page. Question 2. So here the question is that integration of x square plus 1, integration of x square plus 1 divided by x square minus 5x plus 6. X square minus 5x plus 6 dx. This is a classical case, dear students.
The denominator can be factorized.
So here it is, the degree of the numerator polynomial is equal to the degree of the denominator polynomial. Then what to do? You can say, sir, so far you have explained, if the numerator polynomial is greater than denominator polynomial, what to do, and numerator polynomial less than denominator polynomial, what to do. Actually, in this case, we can apply the concept of Euclid's division lemma, isn't it, dear students? Because we can divide the numerator polynomial by denominator polynomial, correct or not? Clear or not clear?
Yeah.
So if we divide, so I should not spend on division, I can just directly write the result. If you divide, you will get something like this, 1 plus, so if we divide x square plus 1 divided by x square minus 5x plus 6, because this is not the class of very basic algebra, so that I should not spend time in dividing. If you divide, you should get something like this: 1 plus 5x minus 5 divided by x square minus 5x plus 6. Got it now?
Yes.
So this is actually equal to what you get: 1 plus 5 into x minus 1 divided by, if you factorize the denominator, you will get x minus 2 into x minus 3.
Yeah.
Correct, no? So the entire integration is now becoming what? Integration of dx, 1 into a dx, no? Plus
Yeah.
5 into integration of x minus 1 into dx divided by x minus 2 into x minus 3. Correct or not? Dear students, correct or not?
Yes.
Now, I hope you can find what is the integration of x minus 1 by x minus 2 into x minus 3. And I want you to find this integration in another 5 minutes from now. You need to perform the integration and you need to tell me what is the value you are getting, because this is actually coming from the, in the table. If you see, it is there. In fact, you can tell me which case of this table is actually fall into this category. Good man, you can answer that. I can go back. Yes.
So it will be in the first one.
Very good. It is in the first form, first case. Absolutely. Very well said. So as it is the first case, all of you can do it?
Yes.
Yes, please do it. And do let me know what is the partial fraction you are getting. Okay. You take some time. Few minutes you take and give me the answer. Disha, is it absolutely clear?
Yes.
Srijita, absolutely clear. Divansu, clear?
Yes, sir.
Divansu?
Yes, sir.
Okay. Rajni, clear, right?
Yes, sir.
Okay, go ahead. Got it? What is the value of, what is the partial fraction representation?
I got 5 integration of 1 by x minus 3 dx minus 5 integration minus 1 by x minus 2. I mean minus
So
5.
you perform the integration. What is that? What is the value you got? What is the what is the final answer? Could you please tell me the final answer?
One second. So I'm getting 5 into ln x minus 3 by ln x. No, that is not fine.
Okay, so let's do it together. Okay, so so how to represent that x minus 1 by x minus 2 into x minus 3, that is equal to capital A by x minus 2. Correct, no, dear students?
Yeah.
Plus capital P by x minus 3. This implies x minus 1 is equal to A into x minus 3 plus B into x minus 2. And you know, dear students, here most preferable approach is to apply the value of x. Suppose you apply the value of x equal to 2. So what we are going to get? 2 minus 1
Yeah.
is
1.
equal to A into 2 minus 3 plus B into 2 minus 2. So from here we can get the value of A is equal to minus 1. Correct, no, dear students? Now you apply the value of x is equal to 3. Okay, so then what we are going to get? It is 3 minus 1 is equal to A into 3 minus 3 plus B into 2. So from here we get the value of B is equal to 2. Correct? So the entire integration, okay, that integration of x minus 1 dx divided by x minus 2 into x minus 3 become minus of integration dx by x minus 2, isn't it, dear students? Plus 2 into integration dx by x minus 3. Correct or not? So that value is equal to what? That value is equal to minus of ln of mod x minus 2 plus 2 into ln of mod x minus 3 and plus 1 integrating constant C1. Correct? Where C1 is integrating constant. Now that value you can apply here, na?
Yeah.
So you apply here, so this value of integration, so what are we going to get? So from here, integration of dx is x. So it is just multiplied by 5, so minus 5 ln into mod x minus 2 plus 10, I'm sorry, 10 into ln of mod x minus 3 plus 1 integrating constant c by, that is equal to 5 into c1 plus the integrating constant by integrating dx. That is the final result. Okay. Clear or not clear?
Yes.
Any doubt here, dear students? Absolutely clear?
Yeah.
Anyone is having any doubt, never hesitate to let me know so that I can discuss. Now we can do another representative problem. Okay. The next representative problem, what I'm going to do is that here it is. Can I proceed, or you need some time to spend on this particular question?
No, sir. It's fine.
Okay. All right. The third question is something like this. Integration of 3x minus 2 dx divided by x plus 1 whole square into x plus 3. X plus 1 whole square into x plus 3. So let me do it. Okay, so you just follow. So now before that, I just have a question to Devanshu. Could you please tell me which case it belongs to in the table?
So could you show the thing?
Table? Yeah, sure.
No, not the table. The equation.
Okay. That I also can also share this thing. It is 3x minus 2 dx divided by x plus 1 whole square into x plus 3. First, you feel comfortable, write down. Then I'll ask you which case of the table is coming. If you say yes, then only I'll move to the table.
Yes, sir.
Okay. Just a minute. Let me move. Yeah. I hope you are able to view the table properly.
Yes, sir.
Yes. Please tell me.
So will it fall into the fourth one?
Fourth. Very good. Perfect. You see that how important that to remember this table. Correct, no? So it is the fourth form. Now, if we go to the fourth form, then what it suggests us, we should express 3x minus 2 divided by x plus 1 whole square into x plus 3. This is equal to, first we write capital A by x plus 1, capital A by x plus 1 plus capital B by x plus 1 whole square plus capital C by x plus 3. Correct or not, dear students? So then what we are going to get? So we are going to get something like this. So this implies left hand side it is 3x minus 2. So that is equal to capital A into x plus 1 into x plus 3.
Yeah.
Plus capital B into x plus 3.
Yeah.
Plus capital C into, you tell me, Mohor, what it should be?
X plus 1 whole square.
Fantastic, x plus 1 whole square. So now what we are going to do, so we are going to, just rearrange the terms, okay? So just simplify it further. So from here, what we get, left hand side, it is 3x minus 2. So we'll get, if we, a into, it will be x square plus 4x plus 3, correct or not? Okay. Plus b into x plus 3, correct or not?
Yeah.
Plus c into x square plus 2x plus 1.
Yeah.
Plus 2x plus 1. So from here, what we get? From here, we get that coefficient of x square in the left hand side is 0. 0 into x square plus 3 into x minus 2 should be equal to a plus c into x square, no, dear students?
Yeah. Yeah.
The coefficient of x square in the right hand side is a plus c. What is the coefficient of x in the right hand side? It is 4a plus b plus 2c.
Yeah.
Correct or not?
Yes.
4a plus b plus 2c into x.
Yeah.
And what is the constant term in the right hand side? It is 3a plus 3b plus c.
Yeah.
So 3a plus 3b plus c. So as we just learned that we can equate the coefficient of x square in the right hand side with that of the left hand side. So what it gives us? A plus c is equal to, it is giving us 0. Then 4a plus b plus 2c, that is the coefficient of x in the right hand side, that should be equal to the coefficient of x in the left hand side, which is 3. Then the constant term in the right hand side is 3a plus 3b plus c. That should be equal to the constant term in the left hand side, that is equal to minus 2. So now you can solve all these three linear equations. I should not spend time here to how to solve linear equations because that we already are aware. But if you solve these linear equations, you will find the value of a. You can do it later, but I can tell you what is the value of a you will get. The value of a you are going to get is 11 by 4. The value of b you are going to get is minus 5 by 2. And value of c you are going to get is minus 11 by 4. Now what we will do, we'll apply back these values here, correct? No?
Yeah.
So then from here, what is the integration we are going to get? So from here, we are going to get the integration of 3x minus 2 dx divided by x plus 1 whole square into x plus 3. That is equal to, a is already there, 11 by 4 integration dx by x plus 1 minus 5 by 2 integration dx by x plus 1 whole square minus 11 by 4 integration dx by x plus 3. Correct or not, dear students?
Yeah.
So once we get these values, we just write it here. We know it is 11 by 4. It is ln of mod of x plus 1.
Yeah.
And what will be the value of integration dx by x minus 1 whole square? It will be minus of 1 by x plus 1. So that minus and minus 5 by 2 will get cancelled. So plus 5 by 2. Correct or not?
Yeah.
Plus 5 by 2 into x
1 by
plus 1. Correct or not?
4.
Minus 11 by 4 into x plus 3.
Yeah.
Minus 11 by 4 into ln of mod x plus. And plus 1 integrating constant c. So this is equal to what? We can write 11 by 4, we can take common. And we get ln of mod of x plus 1 by x plus 3. Correct? Clear or not clear?
Yes.
Plus 5 by 2 into x plus 1 plus c, where c is integrating constant.
Yes.
Any doubt at any point of time, okay, at any step, never hesitate to let me know. Okay. Now I'll suggest you to solve some DPPs today and tomorrow. Okay. And when we'll discuss tomorrow, so I'll suggest you what are the DPPs you need to. Now, along with these DPPs, what I'll suggest you to solve some assignments. That DPP is also assignments, but I'm going to give you some more assignments here along with the DPPs. Okay. Just give me, okay, I'm going to give you some assignments here so that you can work on all those. Okay. So here I'm writing one by one assignments. So this is the first assignment. This is the second assignment. That is the third one I'm going to show you. You will get it in another few minutes. I'll give you, 5 here. Just give me a minute to show you those the last 3 assignments. That is the third one. This is the fourth one. And finally, this is the fifth one. So you can work on this. And now let me tell you, you can go to, you can log into www.KonarClasses.com and log into your online platform. And then I'll tell you exactly what DPP numbers you need to give from integrals. That I'll send you when I'll send you the class notes. So you will get the class notes in another 15 minutes from now, and the entire recorded lectures of today's class in another 2 hours from now. With this, I would like to conclude the class for today, unless you have any specific question for me.
No, sir.
All right, thank you very much.
Thank you, sir.
So our next class tomorrow at 9:30 a.m.
Yes. Thank you, sir.